Okay, so as with all the other chapters, there's an interesting quote at the beginning of this chapter, and this is from Michael Faraday. "One day, sir, you may tax it." And this was in response to a question by Mr. Gladstone, who was in charge of the British Ministry of Exchange or whatever, questioning what was the point in doing all of these experiments with electricity? You know, what's the application? Why should we fund this? And so this is a great example of how there is value to fundamental research, because you cannot develop practical applications, life-changing applications, if you don't know how matter behaves, right? And so a lot of early work, some of it even happens by accident, but people notice something and pursue that. And that's the beauty of pure research, is just being able to explore, and from that, we get a lot of cool stuff. And I think we can all appreciate the value of electricity. So, two ways in which we experience electricity are in lightning and in batteries. And it's really the same principle, just kind of on a different scale, right? So we've all seen lightning, dramatic demonstration. Here's electrical current, electrical charge flowing from a cloud to the ground, or actually more commonly between clouds. Battery works on similar principles. So the driving force for this is that electrons move away from negative charges and toward positive charges. So this makes sense because opposite charges attract each other, positive and negative. Same charges repel each other. So, does anybody know how lightning happens?
The electrons, they flow away from negative charges.
Right, but how do we get the separation of charges? I think that's something that most of us don't really think about. So, in a thundercloud, and we've got clouds today. I'd like to say I ordered them, but I didn't, and they're not giving us any lightning, so it's kind of boring. But there's violent air currents, and so water droplets, which is what a cloud is, collide with each other, and electrons are knocked off of some onto others, and so we get some negative particles and some positive particles. The positive charges accumulate on the ice crystals, which rise towards the top of the cloud, and the negative charges remain on the more slushy, wet bottom of the cloud. Now that might seem a little wrong. Why are the solid ice crystals floating up? What do solid ice crystals do in liquid water? They float. They're less dense, right, than the liquid water. And so we get a charge separation within the cloud, with the positive charges on top and the negative charges on the bottom. And this builds up, and there's a great deal of potential energy there. So eventually, what happens is the air between these two charge separations becomes ionized, which allows conduction of electricity, allows the electrons to move. And that's what lightning is. And so we see lightning happening between clouds or within clouds, and we can also get cloud-to-ground lightning. Okay, not cooperating. Is that it? There we go. So if the cloud gets close enough to the ground, the negative charge on the bottom of the cloud, not that clown, on the bottom of the cloud causes the ground to develop a positive charge. So it's repelling electrons, creating a positive charge on the ground, and then again, it builds up and can form a channel of ionized air, and the charge will flow from the cloud to the earth. And as we know, that can be extremely destructive and extremely dangerous. You do not want to be struck by lightning. Anybody have any questions about that? It's kind of cool, huh? It's chemistry. There's chemistry everywhere. So batteries. think we're all, into batteries, right? I think everybody in here has a cell phone, right? And maybe a laptop or a tablet or a computer, we need batteries, right? So how do batteries work? Well, batteries are made from two substances that have different affinities for electrons. So you have one that has a stronger affinity for electrons than the other. And you separate those and you get a separation of charge. One develops a positive charge, the other a negative charge. And then if we provide a conductive path, like a wire, we can allow the electrons to flow from the negative end to the positive end of the battery. And we can make those electrons do work as they pass through the wire. So we will talk more about batteries. We have to talk a little more about some chemistry first, but any questions right now?